Today I'm gonna do a repair on one of these still relatively good GPUs. First of all, then we're gonna have to do the hardest and I would say the most time consuming part of actually tearing this graphic card into pieces, or at least removing the cooling, of course, so that we have access to the GPU. Regarding now reflow and reball, I don't know how much you can see, but let me zoom in a little. So actually right below the GPU there are some of these tantalum capacitors. Now these are really not loving the heat, even though in this reflow we're gonna put a lot of heat into this area. Now if this would be a card, as an example, where financially it would pay off to put more effort in it, I would actually remove these 3 tantalum capacitors first before I do the reballing. However, in this case I'm just gonna hit it and just hope to get lucky, because one of these tantalum capacitors cost about €3 per piece, and that is just too much money to invest into such a GPU to try to repair it. I mean, you can buy this whole thing for about €100. So this is why it is simply not worth to invest €10 just to try to repair it. Now, one good tip when you are working on such devices like GPUs or especially laptops, that you should definitely take pictures, at least with your mobile phone, of the different stages when you disassemble the hardware, because I can tell you that will make your life a lot easier when you're trying to actually put it back together. Because trust me, you will not remember which screw was where, especially in those cases when the screws have very similar sizes. This is really a issue of confusion. Best is indeed to just then make a picture of every stage. Also to have some sort of small plastic container where you can put in the small screws what you remove. Also, it is a good idea to actually have a small magnet so that they are gathering together in a small area, so they are not getting lost. In the first stage, then I'm gonna remove these hex screws. Once the screws from these sides are removed, then one is then able to actually lift up this thing, and then this exposes this transparent plastic window, which was then sitting on top of the heat spreader. As you see, this is a dirty little graphic card, but actually, yeah, I mean, the hardware will always go full of this very fine dust, mainly because of the electrostatics what is made by the spinning fan. It will charge the air, and this is why the small particles from the air will coagulate, and they will be attracted to the metal on which they discharge. So yeah, this is totally normal for power electronics, which is then being cooled by fans. You should definitely clean out that fine dust from the heat spreader, because even if you manage to repair the card, it will be very soon broken, because this fine dust is not allowing the heat exchange. So it's a good idea to have a compressed can of air or a shop compressor which you can use to clean this thing. Since I'm not working that much on GPUs anymore, I actually don't have any of those two. So I just blow air through it as a human with his lung and clear it out. Next, then I would like to then remove this heat spreader here. This heat spreader is then held down by 4 of these larger screws. The 4 large screws have springs below them, and that is because this spring force is pushing the heat spreader on top of the GPU to put pressure on it to improve the heat exchange. So yeah, next I'm gonna remove these 4 large screws. After removing the 4 screws, then if we lift this thing up, then actually the heat spreader stays on the bottom, and now we already have then the GPU exposed right here. Of course, we still need to remove this plastic cover because, yeah, I mean, we need to heat the whole thing up during rework, and we need also more space around it. The heatsink compound is completely dried out. Yeah, it was not a particularly good quality heatsink compound, I must say. So in addition to drying out, as you see, it totally cracked and formed these small islands, which could have definitely, you know, contributed to this GPU overheating and not making them good contact, because the small balls below the GPU have simply cracked under the heat. And this is why we need to do this reflow or rework procedure. In the next step, to remove then this plastic cover, we're gonna have to remove all these small black hex screws from the bottom side of the PCB, which are then holding the plastic cover on top of the PCB. And in addition to the small hex screws, one also need to remove 2 of these larger screws, which are normal Phillips type, which are then holding down the plastic through these 2 plastic tabs. After you have carefully checked that all the screws which are holding down this aluminum plate and this plastic top are removed, then you can carefully pry up on the thing, and it will take a little bit of force, but not much force. So if you need way too much force, it means you haven't removed all the screws. Now this little force was necessary because, as you see here, there are these silicone pads which actually transfer heat into this aluminum block from some of the components here from the power supply unit. So practically on the card there is an extra power conversion unit, let us call it that way. It's practically a switch mode power supply. And also on the top of the RAM modules there are also these silicone pads, and this is why you need a little bit of force to break that connection loose. But as I said, not too much, so you shouldn't mechanically able to break anything. Take care of that. Once you have then removed this aluminum top cover together with this plastic shroud for the cooler, then you just disconnect the cable here for the cooler, and there is right there one cable below, which is a thermosensor, and it is being connected to this aluminum heatsink. As you see, most of these silicone thermal pads actually came on the aluminum heatsink side, which is a good thing. Personally, I do not like to leave these silicone pads on any of the semiconductor components when I'm reworking a board. And there are 2 reasons for that. First of all, it's gonna make harder to see whether you have some issues on the printed circuit board. Second thing is, I found that if you heat these things up, then they are a complete mess. So then next I'm gonna remove these. So on the aluminum heatsink you can actually see the places where these have been. So I'm gonna remove those pads and stick them here on the aluminum heatsink itself. I do not use any type of glue or something. No, they should just stick on their own. To remove the seal pads, you're gonna need a tweezer. I prefer the one which is about 45-degree bend. Then also you're gonna need a relatively dull, actually in this case it's better to be dull, X-Acto knife or a not so very sharp knife, then you're just gonna grab the seal pad on one of the small corners, slowly lift it up, and work your way through with the X-Acto knife. So the technique is not really cutting, no. It's you slightly push it below the seal pad and then slightly you lift it, and then you have the seal pad nicely lifted without being cut. And then of course once you have one of the seal pads removed, then you can just put it back right away on the aluminum block where it came from. So by the way, these seal pads tend to be quite pricey. They are about 30 to 50 euro cent per piece. So it's a good idea to not mess with them, because as you see there are several seal pads times 50 cents. Trust me, it's gonna cut into your financial gains very quickly. And you're gonna actually clean it only if you successfully reflowed or rebolt the GPU itself, okay? So you are not wasting time on cleaning and such. If you haven't been successful, then there is no point to spend time on that. Then here is the printed circuit board, then completely scraped from the cooling system, and all the plastic components, or at least the major plastic components, are then being removed. Then normally in the next step, since as you see there is still quite a lot of dirt and also there is this heatsink compound, clean then the PCB. And for cleaning, please do not use, I explicitly say, do not use any kind of material which messes up the conformal coating on the PCB. One of the safest bets is to use clean isopropyl alcohol, and this is because some of this conformal coating is actually reacting even with acetone, and especially with methyl ethyl ketone. Yeah, as I said, the best is to use actually clean isopropyl alcohol when you just clean the PCB, because you never know how good or bad of quality the conformal coating is on the board. Since I don't own a ultrasonic cleaner, then I'm gonna do a very cheap workaround. So as I said, I'm gonna use isopropyl alcohol and then just very normal cotton swabs. Even though these are not anti-static, I can tell you, if this thing is dead, this is not what it's gonna kill it anyway. And then I'm gonna clean the whole board before I do a visual inspection on the components first. Now when you are cleaning the GPU of the heatsink compound, what I normally do is that I take isopropyl alcohol again and I just drip it on top of the GPU, so that I allow it a couple of seconds to actually soften the material up, because otherwise it is really tough to remove it. And if this is clean isopropyl alcohol, you should not worry about it, because clean isopropyl alcohol doesn't contain any kind of material which could damage the GPU or the board. And actually I'm using dehydrated isopropyl alcohol, so it is 98% isopropyl alcohol, because I do not want water to go into the GPU, because that increases the chances of so-called popcorning, which is, at the end of the day, it's the delamination of the GPU itself when you heat it up. And that is because the water, you know, it transforms into water vapor, and that literally explodes as it tries to escape from the material itself. Here is then the GPU after the first set of cleaning. As you see, I made some good progress, And then at this stage, it's literally, you know, like in the shampoo commercials, you just rinse and repeat. So I'm just gonna apply a little bit more isopropyl alcohol on the chip itself. Then wait again about 1 minute. So let it then soak into the heatsink compound. And then I'm just gonna work over it with this cotton bud. This is how the chip looks after the second wave of trying to clean it. As you see, there are still some of the heatsink compounds stuck between the small decoupling capacitors on top of the GPU. However, I can tell you that for me this is clean enough. I can at this stage already start to rework the chip, and seriously, do not spend your time trying to make it perfect, because it might be that you cannot fix it. So then you just spend your time on something which not gonna pay you anything. So keep in mind, time is money and our life is not infinite. So yeah, after I go through about twice on a chip, and if it is not really dirty, I mean this one is quite clean, then I'm gonna start and go over the board, and I'm gonna do a physical inspection on the individual components before I do anything. And by the way, definitely do the physical inspection on these power connectors right here, in particular on these solder joints here, because I often find that these solder joints are cracked, and that is no good. If this is the case, then please first of all solder these again. Another big source of failure are electrolytic capacitors like these ones here. So you should definitely check those, especially, you know, looking at them from an angle, and make sure that none of them are bulging. If any of them are bulging, you have to replace those. So yeah, take care of those, remove them and replace them. I have then physically inspected most of the components on the GPU side, and also these couple active components and passive components on the other side of the board. They look all fine to me. Most of these large solder joints here are also fine. So it means that it's highly likely that the issue is indeed with the contacts with the GPU. So then in the next step, then we're gonna reflow the GPU. Once then we have the printed circuit board of the graphic card nicely cleaned, now it's then time to do the actual reflow procedure. So first you should then of course fix the printed circuit board such that the GPU here is really centered with the bottom and the top heater. And yeah, I mean, as you see, it would be a bad idea to install the card like this. It makes more sense to install it like this, because this way there is a lower chance that the board gonna, you know, sag during the procedure. By sagging, I mean that it will bend like this due to the uneven heat between the bottom and the top part of the printed circuit board. To then mechanically install the card, then of course you're just gonna swing out the top heater out of the way. And this is why I find this swinging top heater really practical. Then you're just gonna push these aluminum moving tables, and then you adjust it accordingly that the GPU really sits in the middle. So this is then how I fixed it. As you see, I'm then supporting the board on different places, like here on the SLI bridge part and so forth. And I checked that the GPU is really in the center of the bottom hot air heating element, which I said it is a important thing. Otherwise you're gonna give very uneven heat on the GPU, and that gonna not produce a good reflow of all the balls, which we don't like. So the best is then to melt all the balls potentially at the same time. Of course, the balls which are sitting in the middle of the GPU, they always take a little bit longer to melt, so there is not much what we can do about that. After you fixed the motherboard down, then it's a good idea to then screw these screws in so that these aluminum sliding things are then fixed as well. By the way, do not put extreme pressure or force on the PCB when you fix these things down. No, the PCB should just nicely sit on there, because if you apply force in this direction, when you heat up the board itself gonna get soft, and because of the force from this side, then it gonna bend in the middle, so that's no good. Just leave it nicely on there. I'm gonna then use this nozzle here instead of this one, which I normally put on the machine, because this is on a little bit on the small side for this large GK110 GPU. Next then I'm gonna swing the top heater on top of the GPU, adjust the nozzle that it is really square with the GPU, and of course center it on the GPU on top, and then I lower it such that I leave 3 mm of space between the GPU and the tip of the nozzle. In those cases when I'm doing a reflow instead of a rebore, then I actually prefer to then, once I have adjusted the nozzles, I prefer to then fix everything down mechanically, then also these adjustment knobs, so that nothing is moving mechanically. And that's good because I don't have to take that variance into account. In contrast to that, when I'm reballing, then I need to move the top heater away when I lift the chip. So yeah, that's an entirely different procedure. Now after all these adjustments, now we are then ready to actually start the lead-free reflow profile. And at this stage you should already have your flux ready. Now some of the people put on the flux from the very beginning of the profile when the board is still cold. The thing is that personally I already played around with the profiles and with different printed circuit boards so much that I tweaked my profiles such that I know roughly when does the chip and especially the printed circuit board hits a temperature of roughly 80 degrees Celsius, because I find that as a sweet spot to add actually the flux around the chip. And this is because at this 80 degrees C, the printed circuit board is not soaking that much heat anymore from the bottom plates. And this means that if I put in now the flux around the chip, then the flux will actually run right below the GPU, so it's gonna nicely wet the small lead balls. And that is because if you put the flux from the very beginning on the board, then I find that the flux just evaporates, just burns away, and at the end of the day is not doing the job what it is supposed to do. And this is why I'm gonna actually add the flux in the middle of the profile around the GPU. Now after I turn on the machine, even before I start the profile, as you hear, the machine is quite loud. By the way, that is also a consideration for hobbyists or small machine shops, that these machines generate quite a lot of noise. And because of that, I don't know how well you can hear me now on the microphone with this lapel microphone. So I'm not gonna talk during the profile. Instead, then I'm just gonna, speak over it from the microphone during editing to explain what I'm doing.